Hello students, I hope you are good, well and fine, and today we will be continuing our topic polynomials. And previously we discussed the factor theorems and their exercises, the remainder theorem and their exercises, about the degree of the polynomials and the types of polynomials and different such things. Here and now we will be dive deeper into the how we factorize polynomials. In previous class you saw an example how we did just use the values that saying that we are saying those values or those terms are our factors of the given polynomials. So let's see that how we came to that point that this uh, given linear form of the polynomial is the factor or is a factor of the given polynomial. So let's just see factorization of a quadratic polynomial. So here we will be discussing only for the quadratic polynomial and related exercises. So we know our quadratic polynomial in general will look like this, because here the highest or the maximum value in the power for x is 2. So 2 means the quadratic polynomials, okay, where the one thing is note here is that the coefficient for the x square must be non-zero. Okay, so we will see two methods. One is this completion of square, and another will be the middle term splitting. So first we will see in method of completion of square. So how we will do? So it is just quite easy. So you are given with this sort of polynomial where a is any non-zero, and take first of all take a common out of every term. So you will get a bracket x square plus b by ax plus c by a. Okay, is I hope till this point everything is clear. Now what we will do, we will make a whole square. Okay, so how we will going to do that? So let's just see. So doing just adding and subtracting some term will give me my answer. So let's see what I have to add and subtract. Okay, so x square plus bx b by ax. Okay, now just add b by 2a whole square and subtract the same b by 2a whole square, because you know this both can be just cancelled out. Okay, okay, so but we are not cancelling out, we are just evaluating them further. So this means if I take what I will take. Okay, so if I take this b by 2a whole square, what I will get? Just expand it, b by 2a whole square, you will get a square plus b square plus 2 times ab. So 2 times ab is just 2 gets cancelled and you will left with just b by ax, b by ax. I hope this is clear. And you know x square is already given, you just somehow introduced b by 2ax whole square, and this is already given. So this means I can make this whole terms in just a simplified version like this, x plus b by 2a whole square. Now just making more simplified for this leftover expression, I will use now just make them more simplified. So b square by 4a square plus c by a, and taking the LCM, I will get a times x plus b by 2a whole square, uh, say plus 4a square, which is now this will be 4ac minus 4ac minus b square. I hope now this is clear. So just taking minus common, so this will become b square minus 4ac. I hope this is also clear. So now this is some kind of method of completing of square. Okay, so from this, if you see, you can get the value in by just doing method of completing of square. Okay, so you make square terms. Okay, so now what? Now just see that let's understood by an example. Okay, so factorizing this. Okay, let's see how we will do it. It is quite easy. So first of all, the coefficient is 1, so no need to take a common here, so just use the terms. So what we do, just take this 31 by x and divide it by 2 and add and subtract the squares of it. So subtract and add 31 to x whole square. So this means you will get x minus 31 by x by 2 whole square. Okay, now, okay, so what we used this two terms and this term. So a square, if you expand this, you will get this a square plus b square minus 2 times ab. So 2 times ab, so not x over here, so just the coefficient, half of the coefficient, we are taking half of the coefficient. Okay, so we are just taking half of the coefficient. Okay, so let me see if I did the same mistake over here. So no, so just take half of the coefficient over here. So just taking half of the coefficient of x, what I will get, so I will get eventually 31 by 2 whole square. So you will get in expand a square plus b square, okay, by minus 2 times ab, which will be minus 31x. Okay, so this means we already have 220, we use this, so this means 31 by 2 whole square. This means 31 square by 4. Okay, so just simplify it, you will get your final answer. So let's see. So after simplifying it, you will get this. Okay, I hope this is clear till this step. Okay, and further now, if you see that this was our some say a, so if you take this as a, so this will be my a square, and take this as b, and this will be my b square. So a minus b square is a plus b and a minus b. So just using this identities, you will factorize the quadratic polynomial into these two product of two polynomials. I hope you are very getting clear at every step. Okay, so we just did nothing, just add and subtracted this half of this coefficient for x. So it here it will be x. Okay, so every time just take half of the coefficient of x and add and subtract it, and make the x minus half of the coefficient whole square, depending it, if here it will be x, if suppose the question was like this, then we will use the plus symbol here, but here in this case the question asked for the negative sign, so we use the negative sign. So the sign for here will depends on this, the coefficient of the sign of the coefficient of x. I hope this is clear. Okay, so whole square minus this term, so this term is over here, and this term, so solving this will give me this, and I know 9 square is 81 and 2 square is 4, so it is just 9 by 2 whole square. So making a square minus b square as a plus b times a minus b. Okay, I hope this clears all the things. Okay, so let's move next and do a more examples and questions to understand the factorization method by completing the square. First of all, just take the coefficient of x square common from each term. So now taking this term, this number common out of every term, so that means taking minus 10 common, what I will left with is just this minus 31 by 10x and plus 24 by 10. Okay, I hope now this is clear. Now just take half of this term, so half of this term will, now I'm directly writing it, so minus 31 by 20 whole square and plus the minus 10 is already there, so 24 by 10 and minus, I will use minus here. What I will get? I will get the minus 31 by 20 whole square. I hope this is clear now, but you have to just solve it, solve this, and you will apply some identity over here. So let's see how we approach. So this is quite clear. So first we take minus 10 common and then just adding 31 half of this coefficient and adding half of this coefficient square and subtracting half of this coefficient square there, and just doing x minus half of the coefficient whole square, and this remaining terms, just solve it, we will get this, and we know 1 by 20 whole square is equals to 1 by 400, and then apply a square minus b square over here. Okay, I hope this is clear, and this you can do it by yourself. So my final answer would look like this. So this is my given quadratic polynomial was the product of two polynomials, and each of the polynomials are linear polynomials. Okay, I hope this is clear to you. So that's why from these factorization you can make things and analyze them and give assertion to your original polynomial. So if you analyze them, so you can easily say from this that if putting x is equals to 2 by 3, sorry, 3 by 2, you will get p of 3 by 2 equal to 0, and the same goes for x is equals to 8 by 5, so p of 8 by 5 is also 0. Okay, I hope this is clear. So I'm just using factor theorem over here. Okay, so let's move to next. So now we will see the method of splitting the middle term. So how we are going to split? So here our middle term, what middle term we are talking about, let's see. So here a is my x square coefficient, b is my x coefficient, c is just a constant term. So in the quadratic expression of the form this. Okay, so here we are taking the case a is equals to 1, it is the multiple of x square, and another term are the same as above. Okay, so there are four types of quadratic expressions. Okay, so let's see. So one is this a x square plus bx plus c. Okay, all are terms with positive signs. So in second, just this coefficient for x is minus b. Here the constant term is also for minus b with the coefficient of x. Okay, now here just the constant term I am taking as in negative signs. Okay, let's see what we will do. Okay, so if you see, factorize the 2x square plus 12 root 2x plus 35. Okay, I hope this is clear. So how we are going to approach it? It is very easy. Just a, we know a is this, c is this, just product it. First of all, product them. Okay, so product will give me 70. Now what? Now take what is our b. So my b is this, so this is not over here, just 2x square plus 12 root 2 x plus 35. Okay, so correct the question. So it is not over here. So as I written here, the question is this: 2x square plus 12 root 2 x is not inside the root, it is just outside the root. Okay, so plus 35. Let's see now what we will do. Okay, so we just first of all product with the a and c term and see this a coefficient of x or b is equals to 12 root 2. Now splitting this term, this b or the middle, we know this is our middle term. Okay, middle term. So splitting it like this means 7 root 2 plus 5 root 2. What it equals to? We know it is equals to 12 root 2. And if you product 7 times root 2, or say 7 root 2, 7 root 2 product with 5 root 2, what you will get is 35 times 2, which is equals to 70. So the if you see, the hidden thing is that the product of these two is equals to the product of this a and c. I hope this you can easily see. So my given polynomial or the expression was this. I splitted this middle term into two parts, which one is 7 root 2x, another is plus 5 root 2x. Now what I will do, just take things common out of it. So how I'm taking common? So it is quite easy, taking root 2 common. So from this I know 2 is my root 2 times root 2. So it can be written as 2x square can be rewritten as root 2 times x square plus x root 2x plus 5 root 2x plus okay, and it can be rewritten as 7 times 5. Okay, now what? Now I have written the quadratic polynomial into this expand form. Now what I will do, taking root 2 common, so from here root 2x, I will take root 2x common from here, and here I will left with the 1 root 2x here and just 7 over here. Now taking 5 common, I will left with root 2x plus 7. Now taking this and this common from both of the terms, I will get what I will get. I will get root 2 x plus 7, and inside of the bracket I will left with this root 2 plus 5. So root 2 plus 5. So my factorized form will look like this. Okay, and if you solve it, you will get your original polynomial or the original quadratic form of like this. I hope this clears the middle term splitting procedure. Okay, now let's move and or let's do one more example to polish this concept. So first of all, what we will do is just see the product of this two. So the product is just 24. Now split this 14 in such a way that the product will be my 24. So splitting in 12 and 2, so we know 12 plus 2 will be my 14. Yes, 12 and 12 2 is will be my 24. So I hope this is clear that how we are going to approach. Okay, so let's see the solution now. So I will just split it in minus of 12 minus of 2 because b was of negative sign. So this will become, so x square remains this. Now I splitted the middle term, which is of 12 minus 12x minus 2x plus 24. Now taking x common from this term, I will left with x minus 12, and taking x sorry, the 2 common from here, I am taking minus 2 common here. So the inside of the brackets, the remaining terms are x minus 12. So this is equals to, now taking this and this term, because these both terms are equal to each other, so I can take common out. So I will left with only x minus 2, and this is my common term. So my factorized form will look like this. And if you multiply these two linear polynomials with each other using distributive law, you will eventually get your original form, which is x square minus 14x plus 24. I hope this is also now clear to you. Okay, so I hope you are understanding the splitting the middle term concept. Let's move to next and see one more example. So here what we will do, just now we will do the splitting part for this coefficient. So in order to get so the product for this, what is the product for this? The product for this is minus 1 by 12, if you see, or just 1 by 12. Okay, so what now? So we are not approaching like that, because if you do, you will face some issues over there. So instead of it, we will try to make it in the standard form. Okay, so how we are going to do that? Just take first of all LCM, and you will get your polynomial over here in the standard form. Now take what? Now just multiply these and this, a and c, you will get the minus 48 ac, and b is your minus 13. So how you are going to split b into two parts such that the product will be this? Okay, so we know the 16 times 3 will be my 48. So taking minus 16 and plus 3, you will get minus 13, which is b. And if you product this, you will get minus 48. I hope this is clear why we are taking minus 16 and plus 3. Okay, so now what? Just split it into two terms, which is minus 16 and plus 3. Now taking 8x common, you left with 3x plus 2, and taking just one common, you will left with 3x plus 2. Now taking this 3x minus 2 and 3x minus 2 common, you are left with 8x plus 1, like this, and this is already there the whole time. Now this is my final factorized form of the given polynomial, which was our this. So whenever you face such quadratic polynomials, do not just first simply approach like just this product with this and try to manipulate it. Okay, you will face a very a different issue. Okay, so either you cannot reach to your answer, or you just get worried in between steps. Okay, so first of all, just try to put into some standard form, which is like first of all taking LCM and then making the this sort of form, and then now you can easily manipulate, or first then you can easily perform the steps for middle term splitting. I hope this is all clear to you. Okay, let's move further. So I hope you now the approach for this is clear. So what we will do, first we will try for the LCM. Okay, so taking LCM as 2, you will get 1 by 2 common out, and inside of bracket you will form this type of quadratic uh, expression. Okay, now what? Now just product this and this, what you will get? The product is this 1 0 of 5. Okay, I hope this is clear. So my product is 105. Now what? So 3 times minus 35 is equals to minus of 105. Now how to split this minus 16 in such way that my product is equals to minus 105. So just do that minus 21 and 5. Okay, so if you see, the minus 21 times 5 is my 510, so it is indeed 1 minus of 105, and if you do the sum you will get minus 16 as your answer. So it is quite easy. Now just split minus 16 as minus 21 plus 5, so minus 21 plus 5. Now just taking 3 as common, 3x common out of it, you will get 3. Taking 3x common from this, you will get the x minus 7, and from here 5 you will take common, so x minus 7. Now take taking this x minus 7 common, you will get 3x, this 3x plus 5, and the 1 by 2 was already here for the whole time. Okay, so now the final factorized form will look like this. I hope you are now getting more quicker to solving or to factorizing the quadratic polynomials. Okay, so I hope this clears more and more as you do more and more problem solving. I hope you now understood all the steps very clearly. So thank you for this session. We will meet again. I hope you enjoyed it and learned different methods. Thank you for your attention.